Okay, welcome back. Today we're going to work through Unit 4, Free Response Question B. And Unit 4 is working with contextual applications of the derivative. So we start with a piecewise function, w of t. The depth of a river at a certain point is modeled by the function w, defined above, where w of t is measured in feet and t is measured in hours. First part A, we have to find w prime of 8. So the derivative of w evaluated at t equals 8, and then we have to explain it and use correct units. So let's start with finding w prime of t, but since we're going to evaluate the function at 8, or the derivative function at 8, we need to use this lower part of the piecewise function. So the derivative of 10 is 0. 1/5 is a scalar multiple or a constant multiple. I'm going to leave it. I'm going to use a chain rule, a power rule and a chain rule here. So bring down the 2. T minus 6 to the first, the derivative inside is just 1, and we get w prime of t is equal to negative 2/5 t minus 6. We evaluated at 8, and according to what the AP advises, you can leave it exactly like that after you evaluate at 8. I have a hard time as a math teacher doing that, so negative 2/5 times 2 is negative 4/5. And the units are, it's going to be a rate, since W is in feet, so this is going to be feet per hour, or foot per hour there. So that means that the depth of the river, you can see my screen here, is decreasing at a rate, important to use the word rate in there, a rate of 4/5 feet per hour at time t equals 8. Something along those lines for your explanation. Remember, if they ask you for an explanation, then it's going to be worth a point. If they ask you for units, it's also going to be valued. So you want to make sure you include those things when asked. If you're not asked for units, there's no need to include them. Part B, the graph of W is concave down on that interval. Use the line tangent to the graph of W at t equals 3 to show that W of 3.5 is less than or equal to 9. It's a very interesting part of the question here, involving several different concepts. So number 1, tangent line. Number 2, tangent line approximation. And then number 3, explaining how concavity ties into the tangent line and the value on the function. So let's start with the tangent line. If we're going to find the tangent line at t equals 3, we need the derivative evaluated at t equals 3, because that gives us the slope of the tangent line. So at t equals 3, that's this part of the piecewise function right here. So we're going to need to find another derivative, but this time of the top part of the piecewise function. So the derivative of 17/2 is 0. 3/2 is again a constant multiple or scalar. The derivative cosine is negative sine pi t over 6 times the derivative of the inside, chain rule portion of it, is pi over 6. The derivative of pi over 6t is just pi over 6. So that becomes positive 3/2, and then if we have a 3/2 and we have a pi over 6 here, 3 pi over 12, which should be pi over 4. So we have pi over 4, negative, negative, positive, sine of pi t over 6. Cleans it up a little bit. W prime of t, let's evaluate at 3. Try to do as much as this without our calculator here, although obviously for this year's exams you'll have a calculator at disposal. Sine of, we're going to evaluate at 3 pi over 6 is pi over 2. And hopefully we know the sine of pi over 2 is going to be 1. So w prime of 3 is equal to pi over 4. So we have the slope. We have an x-coordinate t equals 3. So we need to find a y-coordinate. So w of 3, 17 over 2 minus 3/2 cosine, plug in 3, so 3 pi over 6 is pi over 2. So that would equal 17 halves. Cosine of pi over 2 is 0, so just 17 halves. So you have the point 3 comma 17 over 2, or 8.5. So equation of the tangent line, y minus the y coordinate equals slope pi over 4, x minus the x coordinate. Just for the sake of this problem, I'm going to move the 17 halves to the other side. So there is your tangent line equation. What I'd like to do is find the tangent line approximation. So I'd like to find an approximation for the function using the tangent line at 3.5. So 3.5 approximation using the tangent line is 17 over 2 plus pi over 4, 3.5 minus 3. So 17 over 2 plus pi over 4, that's 1/2. So we have 17 over 2 plus pi over 8. Okay, so let's answer the final part of the question here. We have a function that's concave down. So I'm going to draw something, just don't really know what it looks like, but let's say at that interval it's concave down. So we have a tangent line, and this value we just found has to be above the actual value at 3.5 on the function. So this is our function w right there. Okay, so we have w of 3.5 as an approximation 17 over 2 plus pi over 8. Now I want you to think about something. Pi over 8 is 3 point something over 8, so it is definitely less than 4 over 8, which is 1/2. So 1/2 plus 17 over 2 is 18 over 2, which is 9, but this is less than 1/2, so this has to be definitely less than 9. Which means that since this value on our tangent line is less than 9, then the value on the actual function, without a doubt, has to be less than 9. Let's go to the last part of the question here. Find the limit as t approaches 2 of w of t minus t cubed plus 1/4, that whole quantity divided by the quantity t minus 2. So let's take a look at what happens with the numerator and the denominator. So let's evaluate the limit as t approaches 2 of w of t minus t to the third plus 1/4. So that's going to equal w of 2 minus 2 to the third plus 1/4. So w of 2, you're going to evaluate the function at 2, so you're going to plug it into the top part of the piecewise function. So 17 over 2 minus 3/2 cosine of 2 pi over 6, that would be pi over 3, minus 8 plus 1/4. This whole thing is going to come out to 0. Cosine of pi over 3 is 1/2, I believe. Cosine of pi over 3 is 60 degrees. Cosine is going to be 1/2, so we're going to get 17 over 2 minus 1/2 times 3 is 3/4, minus 8 plus 1/4. Something like that. It's going to be 0. Okay, and then we have to take a look at the limit as t approaches 2. Let me see if you can move that up a little bit. As t approaches 2 of the denominator. Using direct substitution, 2 minus 2 is 0. So since both the limit of the numerator is 0, the limit of the denominator is 0, we can use L'Hopital's rule here. So the limit as t approaches 2, derivative of the numerator, w prime of t minus 3t squared is the derivative of t to the third, and the derivative of 1/4 is 0. Derivative of t minus 2, the derivative of t is 1, 2 is 0, there you go. So w prime of 2 minus 3 times 2 squared. W prime of 2, so let's go find w prime of t, but remember we want to use the top part of the piecewise function. So I believe that derivative for numbers between 0 and 6 is right here. So we have pi over 4 sine Plug in 2, so 2 pi over 6 is pi over 3, minus 3 times 4 is 12. And again, using our AP rules, and no need to simplify that, that is in perfect form to answer on your free response question. Thank you for joining me.